Hello there, children. Today we're going to work on section 8.4, solving or working with logarithms. Now, what's a logarithm? Well, I'm going to explain that, so let us begin. So, a log is really an inverse of an exponential function. Now, how do I know this? Well, here's an exponential function, y equals bx plus k. Now, as we know from finding inverses several times this year, what do I do to find an inverse? I switch x and y. But when I do that here, I've got a problem. How do I get y by itself? I can't. Y is in the exponent now, which is a problem. So, what do? Well, I don't know. And mathematicians, to be honest, didn't know either. They knew what they wanted to do. Remember, an inverse is just switching the x and y, like switching an x and y in a t-chart. So, they knew what they wanted to do, but they had no way to actually do it. So, here's what we talk about. They made what's called log form, a logarithm. Logos and rhythm means number ratio, essentially in Latin. Here's the basic form. It's y equals the log base b of x minus h plus k. Now, if you recall, this k is the same as that k. B, so note one here, b is what we call the base. Now, if you know, the base of my exponential function is the base of my logarithm. It's all about that base. So you take care of that. Here is the trick here. K is your vertical asymptote. That's what it was. It's now going to be h is your vertical asymptote. Remember, the asymptote for an exponential was this number. It's now going to be this number. And like we have talked about so many times this year, we are going to do opposite on the inside, which means this is a minus h. We're going to turn that to an h. So what that means is this. If this were x minus 7, our asymptote would be x equals 7. If this were x plus 5, we'd have negative 5 as my asymptote. That's very key here. H is my vertical asymptote. It's the opposite on the inside. Now, where have you heard me say that a ton this year? When we graphed logs, well, yeah, we're there now. When did we see this before? Oh, I don't know. When we graphed quadratics, when we graphed cubics, when we graphed square roots, when we graphed cube roots, when we graphed absolute value functions. Remember I kept saying this is not the last time you're going to hear me say opposite on the inside? Well, here it is again. Now, domain and range is not something uber important to us right now, but in case you're wondering, you're like, this seems weirdly familiar. It is. It's just the reverse of what happened in an exponential function. Now, how to convert from a log to an exponential function. So, first off, the base of an exponential function is the base of a log. That is something that's a given, just so we're clear. The base of an exponential function is the base of my log. So if I had an exponential here that was r to the t power equals p, what's my base? R. What's the base of my log going to be? Also r. And then you switch the values across the equal sign. So you see how this t and this p, they flip-flop. Now, what some people like to do is let's draw a little loop here. See, I go r, loop around. It's called a loop diagram. So I go r to p to t. Look here, r, p, t. If you're converting from a log to an exponential, loop again. R, t, p, r, t, p. The big key takeaway is this r is always going to be your base, and these two things have to switch where they are in the equal sign. It's going to become very important when we do that later this year and later this chapter. Okay, we have to be able to convert from an exponential to a log. The last thing in this section is special logs. So first off, ln. This is the natural log. It is the log base e, like this. Now, in case you're wondering, where the heck did that come from, Mr. Faust? We can talk about that. Now, the thing you got to remember is, where did this come into play? Well, back in the day, these Frenchmen were looking at logs. And remember, e to the x was something we did last section and earlier. And they're like, oh, the log base e. Well, this looked like a mex. They called it a natural log. Now in French, this should be called logarithm naturel, and considering That's what they were studying. Logarithm natural got shortened to ln. ln is a button on your calculator, by the way, as well. So just so you're clear, ln is a button on your calculator. This is one of the two logs your calculator has loaded. What's the base here? It's e. So remember earlier we talked about in our notes that this r is our base. Well, there's no base here because it's assumed to be e. Just like here. This is log base 10 for b is called the common log. Now, why is it so common, you may ask? Oh, I don't know. The metric system. Very good, imaginary voice in my head. It's the metric system there that does that. Oh, happy days are here again. So they don't write it there. So if you don't see a base and you see the word log, it is assumed to be 10. Your calculator also has the log button. Now I know what you're probably thinking. Mr. Faust? Yes, imaginary voice. How do we do things without the base of e and 10? Well, imaginary voice in my head, we will get to that. Don't you worry. So let this all soak in for a minute. Now, just so we're clear, your calculator can do all of these things on it. So there shouldn't be any confusion there. Your calculator has both the 10, log base 10, and the ln button. In case you're wondering where this is, ln is probably close to the e to the x button that you were using, and the log base 10, or just the log button, is close to the wonderful and glorious 10 to the x that you may have been using earlier. Your calculator has these. Again, if you have trouble with a calculator and don't have one at home, please let me know, because one thing you should know is the fact that if you pull up a scientific calculator on your computers, note here I have the log and ln button, and just in case you're wondering, for those of you with the wonderful technology of a phone, if you turn your phone sideways, you have both the e to the x button and the 10 to the x button, but you also have the log button and ln button there as well. So if you click the second key, you will have those available to you. So you have 10 and log 10 right there. You type in the number you want, and you can do it that way. If you don't have a phone or don't have a computer that has a calculator, please do let me know, and I can give you some wonderful and glorious websites that will work for you to do this. So now you have this in front of you. Go henceforth and do. Have fun.